All right, everyone. So this is the first screencast for some of you, and then for others, you know that I do this quite a bit. Okay. What we're doing here is I'm kind of gradually switching into non-review anymore, and we're entering the area here where those of you who were in AB last year, you're going to have to be respectful and of your classmates who have not seen some content. Okay. So we have talked about this phrase right here. The antiderivative of x cubed plus 2 is 1/4 x to the fourth plus 2x plus c. And this word right here, antiderivative, okay, antiderivative means, the function whose derivative is x cubed plus 2. A couple of things that we've noticed when we did some of the questions before is that sometimes when we are going the opposite direction, that means taking the antiderivative, we had to do some algebraic manipulation to see what the antiderivative is. Sometimes it was kind of cleaning up and doing some division. Sometimes it was remembering some derivative rules, like that the derivative of ln x is 1/x, etc. Okay. What I'm going to do in this screencast here is not any new math. There is some terminology. So we have set up until now that the antiderivative of x cubed plus 2 is 1/4 x to the fourth plus 2x plus c. I'm going to introduce some formal language now. That is synonymous with saying the indefinite integral of x cubed plus 2 is 1/4 x to the fourth plus 2x plus c. If you're wondering what does the indefinite integral mean, it means the antiderivative. Okay, so these two are synonymous. This is a new vocabulary word. Mathematically, so symbolically, we could write this sentence symbolically. The indefinite integral of x cubed plus 2 dx equals 1/4 to the one-fourth x to the fourth plus 2x plus c. I just noticed I lost that. All right. The way you say this is down here in quotes. The indefinite integral of x cubed plus 2 dx. A couple of notes I want to make right here. This right here, this dx, for right now, everyone, I'm just going to call this the dummy variable. Okay. What this means, why it's there, why it's x, all of those questions we will answer later on in this year. For right now, I just want you to just notice it. It's always there. There is always a dummy variable when we take the indefinite integral, and you'll understand why, see why it's there, what does it mean, what does it symbolically represent in a minute, or not in a minute, in a while, okay? This symbol right here is called the integral symbol. That is the integral. It is, yes, the big S, Arjun, okay, the integral symbol. And when you have something like this, if you're presented with this, right, this problem and an equal sign, maybe there'll be a question mark to the right-hand side, you should read to yourself and say to yourself, this question is asking me for the indefinite integral of x cubed plus 2 dx. What does that equal? And this is how you say that to yourself, all right? The expression that you are taking the antiderivative of, and in this case here, it is the x cubed plus 2, right? The expression that we are taking the antiderivative of, that expression is referred to as the integrand, okay? So these vocabulary words we need to know. The integrand is that which we are taking the indefinite integral of, or that which we're taking the antiderivative of. This is the indefinite integral symbol. This is just a dummy variable, and that is what we're just going to call it and leave it as such for right now. All right? Which then leads us to be able to evaluate and look at questions like this. Up until this screencast, I would ask you, what is the antiderivative of cosine x? And you would say, cosine x is the derivative of what? Yes, it is sine x. And you would then write it is sine x plus c. This is the same thing. We're doing the exact same math. We're practicing the same exact skill, just with a new presentation. So the indefinite integral of cos x dx equals sine x plus c. Okay? How about this one? The indefinite integral of e to the x plus 3x squared. Okay, you go ahead and pause me and then put your answer down, check with me. Well, let's see, the indefinite integral of e to the x plus 3x squared dx is going to be e to the x plus x cubed plus c, right? Do not forget plus c. Do not forget the plus c, right? There's a constant. Let's do another one. Oh, here's one. You've noticed that sometimes when you are anti-differentiating, sometimes you will have to do some algebraic manipulation. If I look at this right here, there is no derivative rule that I'm recognizing that would yield, that would give me this quotient. However, let's rewrite it together. Let's rewrite this indefinite integral as the indefinite integral of, I'm going to divide each of these three terms by x to the fourth. So I get x to the negative first minus 2x to the negative second plus pi x to the negative fourth. That is my new integrand. Now let's say you are someone who doesn't clearly recognize x to the negative first. We have to remember that x to the negative first is no different than 1 over x, okay? But let's say you tried to apply the reverse of the power rule. And just one more time, the power rule for derivatives is what tells you that x cubed, the derivative of x cubed, it gives you 3x squared, right? Okay, that maybe you're saying, let's see if I can use the power rule backwards. And let's say you didn't recognize that x to the negative 1 was 1 over x. You notice that when you use the power rule backwards, right? If I have 3x squared and I'm trying to get to the antiderivative of 3x squared, I'm using the power rule backwards. What happens is I'm adding 1 to the exponent. That's what gets me to 3, okay? But then I'm also dividing the coefficient by this exponent plus 1 because when I take the derivative, I want to be left with 3x squared, okay? But now, let's see, if you try to do that here and you add 1 to the exponent, and then you divide by negative 1 plus 1, you get x to the 0, which is undefined. And maybe then you'll say, I'm forgetting something, and you are. You're forgetting that x to the negative 1 is 1 over x, and the antiderivative of 1 over x is the natural log of x. Okay, how about the antiderivative of these two terms? Pi is just a number, so don't get intimidated by that. Go ahead and pause and try and complete this antidifferentiation or complete this integration, okay? The antiderivative of negative 2x to the negative second, I'm going to apply the power rule in reverse. Add 1 to the exponent. That's going to give me, let's see, that's going to give me, I'm going to add here. Let's add 1 to the exponent. It gives me x to the negative first. However, when I take the derivative of this, I want to end up with negative 2, right? So I'm going to divide the negative 2 by the negative 1. That negative 2 just came from here, okay? And then this is going to be plus pi x to the negative third, all divided by negative 3. Now, if you want to clean this up, that's not a bad idea. This becomes the natural log of x plus 2x to the negative first minus pi over 3 x to the negative third. All right? Oh, what am I forgetting? Plus c. Okay? All right, let's kind of raise the level a little bit. Let's go over here. Oh my goodness. 4e to the x minus x to the 2/3. So I'm going to share what I overheard Walter and Paige talking about one time, right? When you are anti-differentiating, so when you're working in the opposite direction than we have been used to working, we know that the power rule says that the derivative with respect to x of x to the n equals n times x to the n minus first, right? Okay, well, let's think about this in reverse. If I am going not in this direction, I'm going in the direction of taking the derivative. Well, now I want to think about going in the direction of taking the indefinite integral or anti-differentiating. You've noticed that if I'm looking at, for example, the indefinite integral of 3x to the 7th dx, this equals, here's what we do. We add 1 to the exponent, x to the 8th, and then divide the coefficient by that new exponent. So 3/8 x to the 8th. So what Walter was trying to tell Paige was, he was saying, Paige, you see what you can do here? When I'm going in this direction, anti-differentiating, and I'm working in the reverse of the power rule for derivatives, I want to add 1 to the exponent right here, and then divide by that exponent that I added 1 to, so 8. So 3/8 x to the 8th. So this and this is what's happening. So here, look at number 4. Taking the antiderivative here, not so bad. 4e to the x minus, okay, x to the 2/3. It's a power rule. I know you don't necessarily like this power, but it's just a number. This is not an integer. Add 1 to 2/3. 2/3 plus 3/3 is 5/3. So x to the 5/3. But then you have to divide by that coefficient 5/3. This looks ridiculous. You'd want to clean it. 4e to the x minus 3/5 x to the 5/3. And then what's left? Plus c. All right? So what we're practicing tonight for your homework is taking the indefinite integral. All right? Taking the indefinite integral or evaluating the indefinite integral, or we can call it the verb that it is. The verb is integrating, right? Just like taking the derivative, we have a verb associated with that. We call it differentiating. Integrating an indefinite integral means taking the antiderivative, okay? Means finding the antiderivative. Yes, I know, the rainbow pen is pretty fantastic. I have to agree. Okay, so here's what we're going to do. Let's kind of go with this theme of recognizing derivative rules in reverse. And here is your homework for tonight. I'd like to take a look at page 330 to, let's see, 330 to, this is to page 330 for right now, okay? Let's do numbers. 9 and 11, 13, all right, 21, 25, 27, and let's do 33, okay, 33. And AB, here's people who were in AB last year, I want you to remember I want you to recall how kind of clumsy you felt when you first started working in the opposite direction that you were used to, right? Just kind of remember that clumsy feeling. And, and I think that it's a great practice just to go through and practice it again. It can't hurt. And you know what? I think I'm going to have you right now. Go ahead and do 9C, and then on your own, and then come back and check me, and I'll work them out. Let's say 9C, and let's also do 29. Okay, so 19 and 29. I know 29 is not up here, but go ahead and try those, and then play me for the answers. Okay. All right. 9C is the indefinite integral of x cubed times the square root of x dx. Wow, what does that equal? Well, let's see. I think the first thing I'm going to do is recognize, I'm going to look at the integrand right here and recognize that that is not the output of any derivative rule that I know. But then I'm going to recognize that I can rewrite the integrand as this. And then I can simplify and get to this point. And now I can apply the power rule in reverse. Add 1 to the exponent and then divide by that number. X to the 9/2, all divided by 9/2 plus C. Cleaning this up, I get 2/9 x to the 9/2 plus C. Okay? 29 looks like this. The indefinite integral of sine x over cos squared x dx. Okay, once again, I'm going to look at this and I'm going to recognize to myself that I do not recognize this as the output of any derivative rules, but I can rewrite. Let's see, this I recognize as the same thing as the indefinite integral of tan x times 1 over cosine x, or tan x times secant x dx. Look what I've done. I've just taken this integrand and I've rewritten it. And what guides me in figuring out how to rewrite the integrand is my knowledge of my derivative rules. I know that the derivative of secant x is secant x tan x. So the indefinite integral, or the antiderivative of secant x tan x, is just secant x plus c. Okay? All right, so there you have it, everyone. You can ask people who were in BC Part 1 with me last year. This is a short, very short screencast. Sometimes in this class, your screencasts will be long. This is a short one. And here is your homework. And I will see you tomorrow for some great work to be accomplished. Good night.